Morning, folks. Just checking the audio here. Yep, we're good. All right. So last time in class we went over exceptions. We talked about what an exception is, where it comes from, and we looked at the base exception class, and that under that it had two classes: system exception and application exception. All right. We looked at how to cause an exception, and we looked at how to handle an exception using try-catch blocks. And then we looked at how to create our own exceptions, which was down here. Building your own exception class so that you can throw your own exceptions. And we also looked at how exceptions are thrown using stack trace. So I created a diagram to show you, what is meant by a stack inside of the computer, and how things that are on that stack can throw exceptions and pass it on to the next level of the stack. And so you can end up catching exceptions at different levels. So, we took a look. If you had a method that you knew could potentially throw an exception, you don't necessarily have to catch that inside of that method, as long as whatever code is using that method catches it. So anyway, that's what we looked at last time. So, and then before that we were talking about inheritance, and before that we were talking about objects and classes. So those are the outstanding assignments are related to those topics. All right. And so I'd like to start today with just asking if anyone has questions on any of the outstanding assignments, because I can show, give some help on those. If you're watching this as a recording and you're having a problem with any of the assignments, make sure you email me. I'd be more than happy to meet with you and help you understand what's going on. Because the information the information that we're talking about, from the textbook and in the class, gives you kind of a base idea, and then the exercises a lot of times ask you to implement something that, in a way, you haven't done it or thought of it before. Okay. So here, I thought I had changed this, but it looks like I didn't. The chapter 9 homework was October 15th. The 10 homework was 29th. And then we had the chapter 11 is due tonight. But then it looks like I forgot to push the due dates back on these other ones. So I'll be updating those, pushing them back so that two things aren't due on the same day, because we haven't even gone over chapter 12 yet. So which is what we're going to take a look at today. No one has questions on the previous material. Okay, and then this looks like we're going to be using the the user interface generator of Visual Studio to program a user interface instead of using the console. Based on how many assignments that I've received in the previous chapters, it might be a good idea to, even though there's no one here to ask, I know you guys need the help, so maybe we'll go, go back through some of the main points with using the assignments as a guide. I have met with a few people to work on, to give them help on these assignments, and it is a confusing topic. So, if you feel like you know nothing, I can help you fill in the gaps. Because you know something, it just doesn't make sense with the context of what you know. So, it's going to be hard to fix that with a book, but if you talk to me, we can pinpoint exactly what you're missing and explain it. Things will be a lot simpler. That's called teaching. Okay. So let's see. I think I already talked enough about the chapter 9 homework. Let me remind myself here. Oh, okay. Question on chapter 11. Okay, let's start there. Okay. And that was exercise 2 on page 531, water temp. Water temp. Okay. Here we go. Swimming water temperature. Okay, so argument exception is an existing class that derives from exception. Okay. You use it when one or more of a method's arguments do not fall within an expected range. Create an application named swimming water temperature containing a variable, okay, that can hold a temperature expressed in degrees Fahrenheit. Within the class, create a method that accepts a parameter for a water temperature and returns true or false, indicating whether the water temperature is between these values, which are identified as, I guess, the optimum temperature for swimming. 70's pushing it, I think. All right. If the temperature is not between 32 and 212, it is invalid because you don't want a frozen solid block of ice to swim in, and you probably don't want to swim in boiling water. All right. And so if the numbers are outside of that range, so 32 to negative infinity and 212 to infinity, we need to throw an exception. So, and it says, in the main method, continuously prompt the user for data, temperature, pass it to the method, and then display a message indicated whether the temperature is comfortable, not comfortable, or invalid. Okay. So, are you talking about the return type of the exception or the return type of the method that indicates whether the water temperature is good or not? I guess I could just answer both. So the return type, it's probably not the method, but the return type of the method could be string, or it could be an int of 0 or 1, or a boolean of true or false. Oh wait, it says returns true or false. Okay, well, that answers that question. Right here it says create a method that accepts the parameter and returns true or false. So if it's between 32 and 70, including 70, then it needs to return false. If it is 85, including 85, all the way to 212, between 212 and 85, including 85, it should also return false. And if it's between 70 and 85, return true. Okay. So let's start. That part's fairly simple, and you don't need to add the exception to test to write this part. So it may be better to get that part working first. All right. So a couple days ago, Replit wasn't working. That happens from time to time if it prevents you from completing homework, because whatever time you have to work on homework fell on that time. That's definitely a valid excuse. There are alternative methods to working on it. So if you're worried about Replit not working, you could always use Visual Studio on the school VM. And you could probably do C# web compiler. And there's probably some sites. Here's a .NET fiddle you can use. And so you could test your code, you could work on and test your code in here, and then copy it to Replit later. Just make sure you save it, because I'm not sure this saves anything. Well, it has a save button. Probably just downloads it. Oh, you have to create an account. Okay, anyway, there's going to be somewhere that's fairly easy to find that can compile the stuff. It wasn't that long ago. It would have been a huge hassle, because you would have had to install Visual Studio and have that all set up, and it's not free. Sometimes it's free to students, but getting it's a whole process. Anyway, so let's do, I'm going to do something very similar to what the exercise is asking, but not exact, so that people aren't tempted to just copy it. So I got to come up with that idea now. Checking a range. What's something interesting that we can check the range of? Checking the swimming water temperature. Probably not very useful right now, unless you have an indoor pool. I don't know. Let me know if any of you have an indoor swimming pool in your house. I guess you could go to the Y. I'm assuming those are closed though right now anyway, so maybe you could use it for a hot tub too. Okay, ranges. Let's see. It always has you do financial things, and it always has you do like grades. What's something interesting?
Ideal precipitation.
Well, that would be interesting to me, because I'm trying to set up a greenhouse and I have to monitor the temperature, the air temperature, and the humidity.
I find anything that teaches interesting.
Say what? How about... You can skip ahead, because this is the hard thing, is trying to think of a good example. There's 1.5 million examples. Just drawing a blank here. Okay. So let's take a look at. Actually, let's use GitHub. We'll just look at some trending programs here, and that might give me an idea. Actually, literally any topic. Let's look at science. Science discoveries. That'll help me think of something that might be interesting. Oh, okay. Nah, I think I already did an example of that. Ooh, space travel. Okay. Ooh, I know what we can do. The mass of a star needed for it to convert into a black hole. think it's like 3.49 times the mass of our star, the sun. Okay. A star with the same mass as our sun, In general, stars with final masses in the range of 2 to 3 solar masses, so 2 to 3 times the size of our sun. Alright. Okay, why can't the sun become a black hole? Oh wait, this one is saying the sun would need to be about 20 times more massive to end its life as a black hole. Ooh, and they also explode into a supernova. Alright, let's find the mass of the sun. And let's get to writing the code so I don't run out of time before we do what we're supposed to do. Okay, here we go. The sun has a mass of 1.989 times 10 to the 30th kilograms. That's a lot. It's kind of a lot. Alright. We're going to have to probably round that and you just use a higher value here. So we'll just use a label of times 10 to the 30th kilograms here. So let's make some, I'll make this more coherent. So black hole sun calculator. Careful, you're going to get me a copyright strike. If you think that's wrong. Alright, so let's make some notes here about what we're doing. We have the mass of the sun. We have anyone interested in physics or chemistry, understanding how the world works is very helpful. So it's free to learn. Mass needed for a supernova / black hole is going to be 1.989 times 20. Times 10 to the times 10 to the 30th. So we're just going to ignore for now the 10 to the 30th, and I think even to make it so we can use integers, we can just say that this is, if we take 3 of the, let's test this. Still, let's make sure we're getting the numbers right here. Attention to detail is extremely important as a developer. You have to know when you can and can't cut corners. And when you're working with numbers that need to be specific, that's a time when you don't want to cut any corners. Now, if the user interface doesn't look the best, but it works, probably not as big of a deal. Okay. So we have 1.989 and 20 times, let me zoom in here. Okay, it's not working. Oh, because I have to put that in first. Okay. Alright, so 20 times 1.989. So here's the mass needed. Here's our sun. And so if I took this equals this times well, I think this would be the same. 1.989 to the third should be the same. I'm just double checking that I understand how exponents work here. 1.989 times 10, oh no, times itself 3 times. No, times 10 3 times. So that's 1,000. Versus, yeah, that would make it a whole number. So we can say that 1,989 times 10 to the 27th kilograms. So that way we can use a whole number, and we don't need to use a double. And that means this would need to be 3978, and then we're just going to not care about the next decimal place. 39780 is the mass needed. Okay. So we have our numbers. And let's see. Mass needed for, let's look at mass break points for stars, because I think there's some other stars that can. I know there's a white dwarf. Let's see what a white dwarf is. White dwarf star mass. So a low or medium mass star with mass less than 8 times the mass of our sun will become a white dwarf. All right. So they don't explode and turn into a black hole. They just kind of fall in on themselves and become more dense. So that is, oh no, okay. Mass that's less than 8 times. Okay. So we'll just round that up to 8 times. So we can say equals 8 times this. We'll add another column here. So I remember why we did this. Mass of our sun. You guys know what mass is, right? The old saying, what's heavier, a pound of bricks or a pound of feathers? Well, on Earth they would weigh the same, right? It's an old trick, because people think bricks are heavier than feathers. One brick is probably heavier than one feather, but if you have an equal weight of bricks and feathers, it's the same. But you know, mass is different. Weight is actually just the effect of gravity on mass. So we're talking about mass here. You can Google that if you're curious. Mass of black hole. Mass needed for black hole. Alright, and mass needed for white dwarf. Okay, alright. So this would be 15912 for mass needed for white dwarf. Okay. I'll take those numbers and we'll put them in the comments so that we can look at them and I don't have to keep switching back and forth. And it may have been easier to do this. Times 10 to the it's important to constantly be learning things as a software developer, because technology changes so much, but that doesn't mean you can't benefit from learning other things, so especially math related things. So this taking something times 10 to the power of whatever is a way of shrinking down numbers so they're not ridiculously long to write or to display. And so this is saying this is 1989 with 27 zeros after it. This is this with 27 zeros after it. It's just a shorthand for that. And there are times when they're not zeros, but they're digits. They're just so insignificant that it's okay to display it this way. Depending on what you're doing, the significant value of decimal places is different. So in this case, since we're just doing this as an example, we're cutting corners on our numbers. Anyway, so we have a range now of our sun. What will our sun become? What will the sun become when it dies? Oh, I see. So 8 times our sun and less becomes a white dwarf. What types of stars are there? We need to know about the range, because black hole is a certain size and bigger. White dwarf is a certain size and smaller. What's in between? And there's a whole bunch of other stuff. We're simplifying this. Let's see, a red dwarf. Smallest and coolest kind of star. What about red giant? There we go. 0. No? Okay, now I'm getting confused here. There must be other factors. Kind of just need a chart. Stars and I'll look once and then we'll just move on. Stars and mass chart. All right, here we go. That's surface temperature. So super giants, white dwarfs. Here we go, mass. Oh, they don't have names on here. So it changes the color that they're going to be. There we go. We'll write a neutron star. That might have been what I forgot. Neutron star. Between 10 and 25 solar masses. Okay, there we go. We figured it out. Between 10 and 25. Okay, so we'll just assume we'll simplify that into we have 1 to 8 will be white dwarf. We can just simplify this and just use measurements of the sun. And we'll just make this 1 to 10. 1 to 10 is a white dwarf. 10 to 20. 10 to 20 will be a neutron star. And 20, or no, what is the black hole one? 20 and up.
Yeah, it's supposed to be a true false.
Alright. Alright. So we'll just shorten this to solar masses instead of using these numbers. Okay, so 1 to 20, 10 to 20, and 20 and up. And then we can throw an exception if the mass is 0 or less. That's what we'll do. Alright, now we just enough time to throw this together. Solar masses. Neutron star. Anyone who's a science person that is watching this later and identifying all the errors that I've made in my research and stuff, definitely correct me. I only have a very loose knowledge of this stuff. It's just fascinating, I think. Okay. Black hole. Okay, so we need a method that will return true or false if something's within a range. We're going to change that to it will return one of these depending on which range it falls in. You should be able to reverse engineer that. And so for the sake of time, I'm not going to create any classes for this. I would really prefer if you did for the assignment. And so all you have to do is change this method to be part of a class, and it doesn't specify what classes you need to make, but well, other than the exception class, but you could create a pool class and assign it a temperature, and then have a method that checks the temperature and prints it out, or be creative with it. It just has to have the exception class and be able to test that out. Okay. So I'm just going to do it here in main. In the main class. Public static string. Star result. Right, and so we need to pass in the mass. So that'll be ints solar masses. So we tell it how many solar masses the star is, and it'll spit out what it's going to happen when it dies. And I haven't written in C# since last class, so I better double check that I am doing everything. Okay. Oh, whoops. Return 1. Cannot implicitly convert type into string. Oh, derp. Return test. Okay. So we have the number of solar masses. We just need to write a check to see if it's in the correct range and return the right value. And so what type of structure would be best to use if we needed to test a number to see if it's within 3 different ranges? So our ranges are 1 to 10, 10 to 20, and 20 and up. Actually, let's do, yeah, let's just stick to 1 to 10. But we're going to consider everything above 0 as a white dwarf. Okay, so we have 3 options. We're either going to return white dwarf, or we're going to return neutron star, handy while you're watching this. I know this is a very convoluted roundabout way to answer your question. Don't hesitate to, if I'm not hitting on what you are asking, definitely ask more. Now we want to return black hole if it's too big. So we need paths to return all three of these things, potentially. We want to only return one, depending on the number we have. So what can we use to do that? It's the same thing you're going to use to test the range of temperatures. Let's use if, else if, else. I'm trying to think if there's a better way. So we'll say if solar masses is greater than, actually I think it's easier to start with an if else if. It stops when it hits the correct answer, and so if we start at greater than 20, we want it to choose black hole, and it will only continue on if the number is 20 or less. Right? And so what would our else if be? Well, we're going to go down to the next step, which is any number that is less than 20, those are the only numbers that are going to be tested down here, because if it made it past here, that means the number is less than 20. And so we can write a simple condition here that says, well, of those remaining numbers, if it's greater than 10, it'll be a neutron star. So if solar masses greater than 10, return neutron star. I like how I put them in reverse order that I was going to write the statements in, so I got to keep moving it around here. Okay. And then do I want to use another else if here to test if it's greater than 0? So we could do the error checking with an if statement. All right, so let's try that first. Else if solar masses greater than 0, return white dwarf. And so think about it this way. And then if it's, and we have to include an else here. So else, we can do return. So if it's 0 or less, then I don't know, what is that, antimatter? I don't know. Impossible. Alright, let's make sure I wrote it right. Whoops, I forgot this. And what else did I forget? If, else if, oh. That needs to go on the outside, right? Okay, it's working. So let's try it. We can do console write line star result -15. Alright, it's impossible. But what's different about this structure, the different legs of this structure? Can there be a star with a mass greater than 20? Yeah. So this is returning useful information. it's doing a task where it's telling you the type of star. All right, can a mass be less than 20 but greater than 10? Yes. Can it be this? Can it be greater than 0? To be a white dwarf? Yes. This else, though, we're using this for error checking. Okay, and the information that it's giving is telling us that whatever value is entered is wrong, and it's not telling us what this function is supposed to do, which is just tell us what type of star it is. All right, so the chapter talked about how if you do this, it's hard to it makes it harder to read the code when you use if statements as your error checks. And you also you can't throw that information. You can't take advantage of stack trace and other things. So we don't. So well, we saw that it worked. Let's put another number in there. Let's do regular 15. Right? There's negative 15 and then regular 15. Positive 15. It's a weird way to say it. Okay, so 15 is a neutron star. Oh boy. So you could probably see how this will become water temperatures or whatever. And you can just set this to Boolean to return true or false. In that case, you want to return true or false within a certain scale, and then you want to throw an error. Okay, so here, and again, if anyone is into astrophysics and knows about stars that have negative mass, you can correct me later, but I'm assuming there isn't. Famous last words, right? We, instead of including this in here, we would rather use a try catch, and we could even do it outside of this. So let's go back. So we've got the method working that you would need to use. So now let's talk about oh, I see what they're doing. They actually want you to do this within the exception class. So I'm just adding more work on top of it. So all we care about in our exception is whether the value is less than 100. I'm sorry, 0 or less. If the number is not greater than 0, then we want to throw the exception. Okay, so let's build that exception class. We want to call, oh no, it's an existing class, yada yada. Oh, here we go. Oh, so it actually just wants you to use this existing exception. All right. Should throw an argument exception in the main method. All right, so now on rereading this for after the last video, it's actually very specific about what it wants you to do. Okay. Continuously prompt the user for data, pass it to the method, and then display a message whether the temperature is comfortable, not comfortable, or invalid. So we're going to have it continuously prompt the user for data, solar masses, pass it to the method, and then display a message indicating whether the star will become one of 3 choices or if what you've input is invalid. Okay. Interesting choice that they went away from having you create objects and classes for this exercise, but I guess it's good because it focuses specifically on exceptions. So how do we change this? All right, so let me read it one more time because there's one thing I needed to understand. The method should throw an argument exception. Which method? Within the class, create a method that accepts. Okay, so the method we have in main here, public static string star result. This is what needs to throw the method if it has that exception. So let's see. And so we may just keep with the else, and instead of returning a value within the else, throw the exception. That's what it says here. Okay, if it is invalid, the method should throw an argument exception. All right, so I entirely misunderstood. This isn't about creating an exception, it's about throwing one, an existing one. So let's take a look for the syntax of that. Throwing an exception. I don't think it talks about it back here. I think it's just down here. Okay. Oops. So this last method is like what we're doing down here. Except ours is a public static string, and the assignment will have you do a public static Boolean. And so here, there's no logic. This method just will always throw the exception. We only want to throw it if they've input invalid data, so we can put throw new argument exception and then give it a message. New argument exception. I wonder if I have to add something for this. New argument exception, impossible mass. What did I break? Unexpected symbol. Oh, I forgot my second closing parenthesis. All right, so we got 15 is a neutron star. We already know that. Let's go back. We'll try negative 15. I'm not going to bother adding in the user input part. You guys have done that a million times. Unless you won't, unless someone needs me to do that. Unhandled exception. System.argument exception, impossible mass. So you can put your, does it say what message to put in there for that? Oh, also, please let me know if this answered your question in the chat, Andy, so that I can make sure that I'm helping you out. So this will be, hopefully people are watch these videos, because this is almost giving you the direct answer, but I think it's close enough to have something like this to start from. Oh, I'll post this in the chat, so that way you don't have to look at it in the video and with my incessant scrolling to try to see what I typed. Should have put that sooner. Okay. Well, I guess I wasn't done, so it didn't matter. Okay. So let's see if we fulfilled everything in the assignment here. So, we could catch the error. This crashes the program right now. So we could do try this, and then we could do catch. Let me check the syntax here. Awesome. These are so much better when people show up and ask questions about where they're stuck, because it gives me more things to talk about that are relevant to you guys. So we got a few minutes, so I will we'll take a look at catching the exception inside the method and maybe passing it up, so that you have that in there to clean out when you're doing the assignment. Okay, catching. This is like at the very beginning. There we go. So we'll catch argument exception E. And remember, you can change this to whatever name you want. It could be banana. I feel like it's important for you guys to understand which of these are identifiers that people have created and which are common reserved words. And so when you're writing this, if I want to catch an argument exception, I have to use that as my type here. So I don't get to decide that. I mean, I could just use exception. I would catch any exception. But here, if I only want to catch argument exception or anything that extends from that, I have to use that class name. All right? And if I'm going to try to catch something, I have to use the word catch. Those are not negotiable. The name of the parameter is, well, you can be crazy and call it whatever you want. Typically, you call it E, so that, you know, it's just kind of a standard, or error, or whatever. Something that it's actually related to. Alright, so we can do, instead of crashing everything, we'll just print out a message of try again. So we are catching the exception outside of the method where it's thrown. Alright, well, I guess next time, let's see what chapter 13 is. Handling events. Yeah, we'll need the user interface for that. Let's see what chapter 14 is. Ooh, files. Maybe we'll skip to that. That's much more interesting. Yeah. Maybe we'll skip to that. Once you know how to read in a file, manipulate it, and write it out, you can do a lot of things with programming. So, executive decision, we're going to skip over these for now. Because the way I'm going to have you guys be using, oops, okay, looks like some people did the, well, I'll go ahead and have you still do the multiple choice because it's still something to talk about, I guess. Let's see if anyone turned this one in. Someone did turn it in. So it won't let me publish it. Okay, well, I'll just set the due date to, I'll just set the points to 0. Sorry, whoever did that. I'll give you some, I'll just set it to 0, and if you do it, I'll give you like 5 points extra credit. And unless we do go back and do it. Okay. No due date. It's just a bonus for now. It's definitely not November 5th because we haven't even talked about that. Okay. All right. Well, I think that's enough for now. A little bit of a more bite-sized piece of information for you. If you guys have any questions on anything else, make sure you email me, and it could be something I could go over in class. I don't know why I haven't thought of that before. Instead of doing individual student meetings to teach you all individually the same thing that everyone's having a problem with. Okay. Anyway, have a good day. Contact me if you need anything. And I will end the stream.